Okay, today we're looking at section 2.4. We're looking at finding zeros of polynomials. In section 2.3, we looked at finding zeros as well. We looked at solving it algebraically, which required us to factor, and we looked at doing it on our calculators, where we get decimal approximations for values that aren't exact. Well, we want to ultimately get to the point where we can give exact values even if we have these long decimals that are irrational. To do that, we need to be able to divide. So we're going to start with just some basic skills, which might not be so basic, but we're going to do some long division of polynomials. In order to do that, we need to be able to divide in general. So let's go back to refresh our memory on how we divide. Let's take the number 5,482 and divide it by 23. Okay, I want you to do this with me and have it on your paper because we're going to refer to it a lot. So we set up our long division. We have put 23 on the outside, that's what we're dividing by. On the inside, we put the 5,482. And then we go through a step-by-step process to do the division. To do that, we start by just focusing on parts of the numbers. We take the whole 23, but we say, what does that go into 5? Well, it doesn't. So then we look at the next two digits, 54. Does 23 go into 54? It does. It goes in 2 times, so we put a 2 on the top. And we multiply the 2 times the 23 to get 46. And then hopefully you remember what you do. Hopefully you're thinking we subtract. And so we do. We subtract. 54 minus 46 is 8. 23 doesn't go into 8, but if you remember from when you learned this a long time ago, what we can do then is bring down our next digit. That 8 comes down and makes that 88. And then we ask how many times does 23 go into 88? Well, it goes in 3 times. And we multiply 3 times 23 and we get 69. And then just like before, we subtract that. 88 minus 69 is 19. Then 23 doesn't go into 19, so we bring down the next digit. We bring down the 2. And we say, how many times does 23 go into 192? Okay, we might have to do a little thinking on that. We do come up with the fact it goes in 8 times. And so 8 times 23 is 184. And we subtract. When we subtract, we get 8. At this point, we need to decide what we want to do. It doesn't go in evenly. We have a remainder. And so some of you might remember you put a decimal and some zeros and you keep going. Okay, that's a possibility. We also had the option of maybe just simply saying there's a remainder of 8. There's a third option that you probably don't remember quite as well, but that's the one that we like the best, actually. We have a remainder of 8 out of 23. So we can actually add this fraction and make it a mixed number of 238 and 8/23. Okay, that is the exact answer to the division. Okay, we're going to refer to this, so keep looking at that as we do a long division with polynomials. So here it asks us to use long division to divide the polynomials f and d. So here's f, here's d. So I want to divide this by this, so we're going to set up right small. There's not a ton of room here. Okay, what I'm dividing by is x squared plus x plus 1. What's being divided is 2x to the 4th plus x cubed. Notice there's no x squared here. When there's a missing term, we need to include it. We're going to put 0x squared. There's no x either, so we're going to put 0x, and then we'll have the minus 3. Okay, let's make a note so we don't forget to do that. We need all terms, which means we need to put zeros for any missing terms. Okay, now we're actually going to do the long division. Looking back on our long division before, we didn't take 23 and the whole number 5,482. We just looked at part of it. Well, similarly, we're going to only look at part of it here. We're going to look at the first terms, the 2x to the 4th and the x squared. Okay, let's write that down. We're going to focus on the first terms. The question's going to change a little bit. I'm not going to say how many times does x squared go into 2x to the fourth. It's still the same question as saying, what do I multiply x squared by to get 2x to the fourth? Okay, hopefully you're thinking 2x squared. I'm going to write that in line with the x squared term so that I actually have it all lined up neatly and it helps me figure out when I'm done. Then I have to take that value and I have to multiply it. Just like we took the 2 and multiplied 23 to get 46. So we take our 2x squared, we multiply it by x squared and x and 1, and we write our answer underneath. So we get 2x to the fourth plus 2x cubed plus x squared. Okay, looking back on what we did before, we did 2 times 23 to get 46. We wrote it underneath. Then we subtracted. So we need to subtract. To remind ourselves to subtract everything, putting those parentheses is helpful. Okay, subtract everything. 2x to the fourth minus 2x to the fourth is 0. X cubed minus 2x cubed is negative 1x cubed. X squared minus x squared, 0x squared minus x squared is negative x squared. Okay, just like before we brought down the 8 here, we want to bring down the next term, the 0x. Then everything repeats. We have x squared, and our first term here is negative x cubed. So we say, what do I have to multiply x squared by to get negative x cubed? Hopefully you're thinking negative 1x. Then I multiply that negative 1x times the whole trinomial to get negative x cubed minus x squared minus x. Then we subtract. As we subtract, negative x cubed minus x cubed is 0. Negative x squared minus a negative x squared. Something's wrong there. What did I do wrong? Oh, back here. I made a mistake. That should have been 2. So this should be a 2. Sorry. Now I have negative 2x squared minus a negative, so plus x squared is negative x squared. And then 0 minus a negative plus x, and then bring down that 3, minus 3, bring down that negative 3. Okay, one last time. What do I have to multiply x squared by to get negative x? Negative 1. And so we get negative x squared minus x minus 1, multiplying negative 1 times that trinomial. And lastly, we subtract that. We're at the end, so we know we're getting to the end. We subtract here. X minus a negative x is 2x. Negative x squared minus negative x squared is 0. Negative 3 minus a negative 1 is plus 1, so negative 2. Okay, that's the synthetic division. Now, how do we write our answer? Well, like we had up here, there's a couple different ways we can do it. We're going to look at the fraction form first. The fraction form is actually giving us our answer. This is the quotient. Q-U-O-T-I-E-N-T. Okay, quotient. That's the answer to the division. So fraction form says I got the answer 2x squared minus x minus 1. Okay, and then like we made our fraction here, our remainder over what we divided by. Now here, since it's a polynomial, we need to add between all of our terms. We're going to add 2x minus 2 over the whole x squared, what I divided by, squared, plus x plus 1. Okay, that's our answer to the division. If the problem simply says divide, this is really what we're looking for. But a lot of times what we're doing division for is to factor. And so the polynomial form says write this out in factored form because the factored form is actually what the original polynomial is equal to. This f of x squared can be, or f of x can be written as the product of what I divided by, x squared plus x plus 1, times the answer I got, 2x squared minus x minus 1. And then I have to, those two together aren't enough. They multiply close to what I want. But there's this remainder. So I need to add that remainder on. Okay, then if I were to multiply those two together and add that remainder in, I would actually get back to the original f of x. Okay, I might actually think of this as the factored form. All right, that's the process of long division. If that was smooth and you understood it, fantastic. If not, either revisit this Or look at the other video that's here by Ms. Trent. She did a video on long division that you can use to practice this a little more, because we're going to go ahead and go on to the next piece of content. When we're factoring with polynomials, the goal is often, when we're dividing by polynomials, the goal is often to factor. And so one thing we need to understand is the idea of remainders and what remainders tell us and how to find a remainder with a shortcut. Okay, this remainder theorem says that if I'm dividing by a factor specifically in this form, it only works in this form, there's a shortcut to find the remainder. The remainder is found by putting whatever this k is into the polynomial and simplifying. So we're going to try that. We'll come back to the factor theorem in a moment. Here, we're going to divide this we want to know what the remainder is. We're not actually doing the division, but we want to know what's the remainder when I take this polynomial here and divide it by x minus 3. All right, so it is in the form of x minus k, and so in this case, my k is 3. I can find the remainder using the shortcut f of 3. So putting 3 in for all the x's, 2 times 3 squared minus 4 times 3 plus 2. If I simplify that all out, 18 minus 12 plus 2 comes out to be 8. So the remainder, if I were to actually divide those, would be 8. Okay, here we have x plus 3, so that means my k, if it's x minus k, has to be negative 3. Okay, I want you to just do the same thing. Find the remainder, so do f of negative 3. Okay, try that for b and c. Okay, I'm going to stop this video and then start the next video and you can check your answers on that.